Okay, so we're going to walk through this question. The lattice enthalpy of silver fluoride is -958, and for sodium silver chloride it's -905. So explain the difference in the lattice enthalpies of the two silver halides. So if we look at silver, which is Ag+, and we're putting it with F- or Cl-. So we've got two different sized ions there. Silver fluoride has a lattice enthalpy of -958. Silver chloride is -905. So we can see that silver fluoride is much larger than silver chloride, and that is all to do with size of ion. So the fact that chloride ion is a bigger ion, the negative charge on chlorine, the chloride ion, is spread over a larger surface area. So the attraction for chloride to silver is going to be less just because it's that bigger ion. So that answers the first question for the difference in enthalpies. There will be a stronger bond between the silver and the fluoride ion than there will be between the silver and chloride ion because of the ion sizes. So the second part of this, explain the difference in enthalpies of hydration of the two halide ions. So here we've got fluoride and chloride. And looking at the information, we know that the enthalpy of hydration for the fluoride ion is -506 kilojoules per mole, and for the chloride ion is -364 kilojoules per mole. We can see that this hydration enthalpy is much greater for the very smaller, more compactly densely charged fluoride ion than the chloride ion. So it's a similar answer to before. The forces of attraction that we have between the negatively charged fluoride ion and the delta positive of the water is much greater than the forces of attraction between the much larger chloride ion and less densely packed charge of the chloride ion to the delta positive side of water. So the size of the ion here again dictates the strength of attraction. So part C asks us to draw separate enthalpy diagrams for silver fluoride and silver chloride in water. So let's start with silver fluoride. So silver fluoride is a solid, and we add it to water and we will form silver ions, aqueous silver ions, and aqueous fluoride ions. Okay. We've also got the same with silver chloride. So I'll just replicate that underneath here. So silver ions and chloride ions. Okay, I'll just move that slightly. We also need the lattice enthalpies. So here we can have gaseous silver ions and gaseous fluoride ions. So lattice dissociation enthalpy to give us the individual ions, and then here we've got hydration of silver ions and hydration of fluoride ions. I'm going to just write on the values here. So it gave us the lattice enthalpy of silver chloride, and it's 958, and that would be the lattice formation enthalpy. And I've actually I've drawn the lattice dissociation enthalpy, but we know that this is the exact opposite. The formation enthalpy is the exact opposite of the dissociation enthalpy. So the enthalpy of dissociation here would be +958 from this value. The silver ions, hydration of silver ions is -406 446, so minus 446, and hydration of fluoride ions is minus 506, minus 506. So this is what we wanted to find, the solution, hydration energy enthalpy of solution. So the hydration enthalpy of solution is equal to plus 958 minus 446 minus 506, and when we do that calculation, so that calculation would come to plus 6 kilojoules per mole. That's what we've been working with. Okay, so we can do exactly the same. We can do the same things to the silver chloride, and I'll just do that now. I'll just set up that diagram. Okay, so here's the same diagram, but putting chloride ions in instead. So we can pick up that we need to calculate this solution, enthalpy of solution, from what we have here. The lattice enthalpy for silver chloride is minus 905, and because it's negative, that's the formation of the lattice. So we're doing dissociation of the lattice, so it is the opposite way round. So we're having to put energy in, and that's plus 905. Can't see that particularly well. Let me just 905, and that's going to go down there. So it's plus 905. The silver we already had previously, that doesn't change, it's minus 446, and the chloride ion, for hydration of chloride ion is minus 364. So we can do the same calculation. So this enthalpy of solution equals plus 905 minus 446 minus 364. I'll just go ahead and do that calculation. You can see me do it on here. Clear that. So 905, take away 446, take away 364 equals plus 95 kilojoules per mole. You can't see that particularly well. Let's just, there we go. So you can see that a little bit better. So the hydration enthalpy of solution is plus 905, take away 446, take away 364, and that would give us plus 95. Okay, so if we go back to the question, draw separate enthalpy diagrams, which we have here and here, and we've linked together the lattice enthalpy and the hydration enthalpies. We've used that to calculate the enthalpy of solution for silver fluoride, which is plus 6, and for silver chloride, which is plus 95. Now, finally, the question is, what do the values of the enthalpy changes of solution suggest about the solubilities of the solids in water? So what this is showing is that it's going to take a little bit of energy to dissolve silver fluoride in water, whereas this is going to take a lot more energy to dissolve silver chloride in water. So silver fluoride at room temperature is probably going to be a lot more soluble than silver chloride at room temperature. But if we link that to our silver halide tests, when we test for whether a chloride or a bromide or an iodide is present, we never test for if a fluoride is present, because we wouldn't see it at normal temperatures, at room temperature, because silver fluoride is soluble. So just a little bit of room temperature energy will help dissolve silver fluoride, but we'll need more than room temperature energy to dissolve silver chloride. So silver chloride is less soluble in water than silver fluoride. Okay, so I'm hoping that that question, working through that question, has helped you. This is the sort of A-level question that you would get. It links on, and then there may be a link to another part of the syllabus. And as you can see, I brought a link in for doing halide tests or for testing for silver that you might have to do.